Water Management in the 21st Century Dr. Nelson R. Gittell. Part 2. Exploring Aquifers, the Hidden Water Source. In the face of increasing global water scarcity, exploring all potential sources of this vital resource is essential. One such source lies hidden beneath the Earth's surface: aquifers. These natural underground reservoirs hold vast amounts of fresh water and are critical to life as we know it. This video delves into the fascinating science of groundwater and aquifers, offering insights into their geological formation, the mechanisms of their replenishment, and the threats they face due to over-extraction and pollution. The geological formation of aquifers. Aquifers are permeable, water-bearing geological formations that store and transmit groundwater. They typically comprise porous materials like sand, gravel, or fractured rock, which can hold and share water. The formation of an aquifer starts with the hydrological cycle, the continuous process of water circulating between the Earth's surface and the atmosphere. Rainwater or melted snow seeps into the ground, which is known as infiltration. As this water continues to move downwards through the soil and rock layers, it eventually reaches a zone where all the spaces in the rock are filled with water. This is known as the water table, and it marks the upper surface of an aquifer. Replenishment of aquifers, the slow process of recharge. Aquifers are replenished naturally through a process called recharge. Recharge primarily occurs when rainwater or melted snow infiltrates the ground and percolates to the aquifer. However, the rate at which this happens can vary greatly depending on factors like the permeability of the soil, the amount of vegetation, and the intensity and duration of rainfall. Aquifers can also be recharged artificially through methods like injection wells and water spreading over recharge basins. It's important to note that aquifer recharge is slow, often measured in decades or even centuries. This means that the extraction rate can quickly outpace the replenishment rate if groundwater is not managed sustainably. The threat to aquifers: over-extraction and pollution. The convenience and abundance of groundwater make aquifers attractive agricultural, municipal, and industrial sources. However, excessive extraction can lead to the depletion of aquifers, a phenomenon known as groundwater overdraft. Overdraft can cause many problems, including the drying up of wells, reduction of water in streams and lakes, land subsidence, and the deterioration of water quality as the water table drops. Aquifers also face the risk of pollution from various sources. Contaminants can seep into the ground, pollute the aquifer, and unfit the water. Familiar sources of groundwater pollution include agricultural runoff, septic systems, and leaking underground storage tanks. Conclusion. Our hidden water sources, aquifers, are vital in sustaining ecosystems, agriculture, and human settlements. Understanding groundwater and aquifer science is critical to effectively managing these precious resources. Sustainable groundwater management becomes more crucial as we face increasing water scarcity due to climate change and growing demand. Our collective responsibility is to protect and conserve these natural reservoirs for current and future generations. Only by doing so can we ensure a reliable, clean water supply, a fundamental right for all and a cornerstone of sustainable development.